first. And the first thing that I'm going to share with you is about 109 degrees below 0 Fahrenheit. All right. Okay. So this is dry ice. And dry ice is made of carbon dioxide gas. Where do we find carbon dioxide gas? Let's see. Anybody? Anyone? You could just say it. Yeah, in the atmosphere, and we exhale it, right? Yeah, plants and trees. Yeah, so this is the frozen form of carbon dioxide. Now you can see here that it's kind of giving off this steam or this gas. But what it's not doing is it's not melting. Like a regular ice cube that we would pull out of our freezer in the kitchen, it's made of a freezer from the ice cube in the kitchen? Wait.
Water.
An ice cube from the freezer in the kitchen is made of?
Water.
There we go. Whew, it's early, right? Okay, it's made of water, and when we pull it out of that freezer and put it on the kitchen counter, what's it going to turn into after a while?
Water.
Yeah, it's going to go from a solid to a liquid. And then is that liquid going to stay on the counter forever? No. What's going to happen to it?
It's going to evaporate.
Thank you. It's going to evaporate, so that means that it's going to go from a solid to a liquid to a gas. But right here, since our dry ice is not made of water, it is going from a solid to a gas. And that's called sublimating, or the process of sublimation. Okay, so that is just one neat thing about dry ice, but there's more. Here's some room temperature water. So we're going to see what happens when our dry ice reacts to that room temperature water. Should I put some more in?
Yeah.
Yes.
As boss.
Ooh. Can you hear that?
Yeah.
So our dry ice is still sublimating, and it's making bubbles in the water. But how is this fog happening? Does anybody want to take a guess? In the back, yeah?
Because chemical reaction is causing it to happen?
There is some reaction happening, yes. You want to add to that?
Evaporation.
Evaporation, perhaps. Any other thoughts, guesses, ideas? Yeah? Gives off more gas. That's what's making the bubbles, is it giving off more gas. What's making the fog is the difference and the reaction between the very, very cold dry ice and the warm water. Because it's room temperature, it's about 70 degrees Fahrenheit, 70 degrees above 0. And our dry ice was 109 degrees below 0. So that temperature difference creates this fog, or this gas. Similar to the way that fog is created in nature, that warm air and the cold air will collide to create fog. Clouds are made this way too. Okay, so we got one more thing we can do with our dry ice. Got some soapy water here. And I'm just going to create a soapy film on the top of the jar.
That's boss. That's awesome.
So we're just going to make a bubble here.
Making a really bubble.
So when you use a bubble wand, the kind that you can use your breath to make a bubble with, you dip it into the soap, and it makes a soapy film, right? And then you use your breath to blow the bubble. This is a similar idea. We're putting that soapy film on the top of the jar, and then the gas is filling up underneath that soapy film and making a bubble. Should I pop it?
Yeah.
No.
So you can see it's just made of the fog that we created with our dry ice. Adults can buy dry ice at the grocery store. Some people use it, whoa, I guess we got some soap in there and it's bubbling over. Well, that's kind of cool. So each of these little bubbles has got fog in it too. Whoa, bubble machine. Sweet. So yeah, adults can buy dry ice at the grocery store. They might use it for extended fishing trip. And sometimes if you buy products that need to stay cold, let's say you want to send some ice cream to somebody, it can be mailed with dry ice and it'll stay cold. So dry ice, yes, it's very cool. It's 109 degrees below zero. But I have something that's even colder to share with you. It's about the same temperature as outer space. So NASA gets to use this stuff a lot to make sure that they can test their equipment to withstand those cold temperatures of outer space. Carefully put this over here. Eventually that dry ice will just sublimate away and it'll be gone and there won't be any more bubbles, bubbles of these kind, or fog. But our soap, I'm not sure how long that's going to last. All right. Let me know if you see a solid, a liquid, or a gas going in here. What do you think?
Liquid.
You can say it out loud.
Liquid.
Liquid, okay. Anything else?
Gas.
Yeah, seen both. So this is liquid nitrogen, and it's 320 degrees below 0 Fahrenheit. And since it's not 320 degrees below 0 Fahrenheit in this room, it warms up. It's actually always boiling because it cannot stay that cold, just the way that we store it. But when I move it around, that heats it up a lot, so that makes it steam up and boil a lot more violently. So if you've seen anybody boil water, you've yourself boiled water on the stove, do you know what direction that steam goes? Point in the direction that that steam goes. Right. So hot air, gas, steam, it rises. But our steam, even though the liquid nitrogen is boiling, our steam sinks because it's very cold. So cold sinks and heat rises. All right. Try a couple things with our liquid nitrogen. Okay, this one's going to take a little bit, so we're going to get it started and then we'll come back to it. All right, let's make some observations about these two things. Who wants to tell me an observation that they can see? Yes, right here.
They're gonna freeze one of the bubbles and it's gonna.
That's not an observation.
Spoiler alert! No. Well, let's see. Just tell me an observation. What do you see about these? Yeah.
They look the same.
They look the same. Yes. Anything else? Yeah.
They're bouncy balls.
They're, how do we know? Should I try it? You're right. Okay. They're bouncy. They look the same. They're the same shape, size, color. One of them's about to get very cold. We're just going to dunk it in the liquid nitrogen. And the other one will be our control. So that means that we'll just leave it at room temperature and not change it. We'll see what happens to it after a little while. Okay. In the meantime, see what happens when we move our liquid nitrogen to a different container. Okay. Also, check it out. What's on the outside of my beaker? It's frost, yeah. So the moisture in the air got stuck to the side of the beaker. It froze there and made frost. So that's why I have to wear this thick glove when I hold onto this beaker, because the moisture in my hands could get stuck to the beaker and that would really hurt. All right, so we're just gonna put our liquid nitrogen in here for a while. I'm gonna pop the lid on here. Well, there you go. Okay,
I don't know if that was supposed to happen, but that was
let's try this again. Okay. Woo. Why won't the lid stay on my Pringles can? Anybody figure it out? Let's see, who haven't I heard from? In the orange here?
Because except the liquid nitrogen is releasing gas, the lid gets pressure.
Yeah.
Hold in.
told you.
Exactly, it's building up pressure. Yeah, so remember that liquid nitrogen, it's turning into gas. We can see the gas just kind of billowing out of that little container there. And since we've got this tight-fitting lid, the pressure that builds up in the container, the gas makes pressure. It's pushing on the outside. It doesn't want to be stuck in there. So that pressure explodes the lid off the top. So it's a little cold explosion for you. One more time. You ready for this one? Ooh, that was a tough one. Wow. All right. the extra back in here. All right, let's see what happened
To the ball.
to our racquetball. This one didn't change at all because we just left it here at room temperature. Okay. Okay, well, is it the same size? Is it the same color? Same shape? Seeing something that's telling us that it's a lot colder. It's got that steam going down, right? Yeah, it's definitely colder. Well, let's see if it's both, if they're both still bouncy. We'll do the bounce test. So this is our room temperature ball. That's our cold ball. Huh. Okay, room temperature. Cold. Do you hear the difference in the sound it makes when it drops? Okay, we're gonna try one more thing. It's a nice brick wall back here. Okay, so I'll just throw this room temperature ball. Woo. Bouncy. Now I gotta put my glove on for this one. Okay, let's see what happens. So we know that it didn't really bounce on the floor. So I wonder what's gonna happen when it hits the wall. Ready? 1, 2, 3. Whoa. Spin it around.
It shattered.
Still steaming.
It shattered.
Yeah. Yep, racquetballs are hollow. So the molecules that the rubber is made of, they got very cold and they got closer together, or they contracted. And instead of being bouncy, the rubber of the racquetball shattered like glass when it hit the floor. No, it's not really doing much of anything. It will warm up though, and it'll be squishy again, but I'm not going to be bouncing it ever again. Alright, I really like that experiment.
You could have
I
seen
like
it's long.
breaking racquetballs. It's fun. Alright. So that does it for the cold stuff, the extreme cold temperatures.